Hello, my dear friends. I am Shubham from LearnoHub, the free learning platform where you can study physics, chemistry, maths, biology absolutely for free at learnohub.com. So then, let's start. So, as you all know, we are going to continue your ICSE class 9th chemistry chapter number 3, water, in this video lecture, and this would be the last video lecture for this chapter. We are going to cover the remaining concepts of this chapter in this video itself, and after that we are going to check whether how much we have understood, what all things we have studied in this video, whether we have understood it or not, with the help of some questions. Okay, so without wasting much time, let's start and let's rock. So before starting, the kid says let's first of all go through the topics which we are going to study in this video lecture. So which is simply what is soft water, what is hard water. I'm definitely sure you would have heard these terms, okay, somewhere or the other. So now let's study what are those. What is soft water, what is hard water, then what is the cause of hardness, what are types of hardnesses, how we can remove the hardness, and what are the advantages and disadvantages of hard water. Okay, so let's not waste much time here. Let's quickly jump on to the first topic. What is soft water and hard water? Okay, so let's start with the scenario. Suppose you want to wash your hands and there is only soap present, and what you're going to do is you took the soap. Okay, first of all you wetted your hands, okay, slightly okay, by opening the tap, and then after that you are rubbing the hand onto the soap, but the soap is not, but you are not able to make some lather. Okay, so this means that there is something wrong. Okay, and whatever thing is wrong is in the water, it's not wrong in the soap. Okay, so such water which does not give lather readily, okay, is called hard water. Okay, and now in the normal scenarios, you take the soap, you take some water, and then you rub the soap, and you can see the lather is forming readily. So that water is soft water. So water which forms lather with the soap readily is soft, whereas water which does not form lather, okay, with soap readily is called as hard water. As simple as that, very simple. Now, moving ahead, why the water is called as hard water, or what causes the water to become hard? Okay, why the water is not forming lather readily? Now, the reason behind this is this water, okay, which we so called it as a hard water, this has the bicarbonate, okay, chloride or sulfates, okay, of calcium or magnesium. Okay, now let me make you understand these things. I will simplify this thing. This means that this water, okay, which we call it as a hard water, consists of either calcium, okay, bicarbonate, or magnesium bicarbonate. Okay, these two salts, either of these two salts, or okay, or calcium chloride or magnesium chloride. Okay, so either of these four salts, if any one of the salt is present, then the water is hard. Okay, try to understand what I'm saying. And then the next two are calcium sulfate and okay, magnesium sulfate. Okay, so these, out of these 6 salts which I have written here, if any of this salt is present in our water, then this means that our water is hard. So I have just summarized this in the form of this sentence. Presence of bicarbonate, see, bicarbonate of calcium or magnesium, right? Bicarbonate of calcium or magnesium, we call this anion as bicarbonate, HCO3 minus, right? Then or means bicarbonate comma chloride of calcium or magnesium. So chloride of calcium or magnesium, right? Of calcium or magnesium. And then sulfate of calcium or magnesium. So see, sulfate of calcium or magnesium, right? So any of these 6 chemicals or 6 salts, if they are present in water, then our water is hard water, right? If any of these 6 salt is not present in water, then our water is called as soft water. Okay, please make this thing clear in your mind, right? So apart from this salts, if any other salt is present in our water, then that is soft, right? Okay, but this, out of these 6 salts, nothing should be present in our water, then it is soft. If any of this is present, then it is a hard water. Okay, I hope it is clear to you. So let me make you understand much more easily now. See, suppose now where we can find this such type of water, hard water or soft water. Okay, let's see that. So suppose the river is flowing. Okay, so this river, okay, is flowing over the rock bed or something like that, okay, over the soil, and this soil we know has so many minerals in it, right? And now, like, minerals means so many salts like this. Okay, so some of the salts may get dissolved in our water. So if the salt which gets dissolved in water is any one of this, then our water becomes hard, correct? For example, suppose calcium sulfate, okay, is present in the soil or on the rock bed over which our water is flowing. So that calcium sulfate gets dissolved in water and then our water becomes hard. Okay, so in the same way, for example, suppose our water is flowing through limestone. Okay, take a scenario. So limestone, we all know it's calcium carbonate, right? Or suppose our water is flowing through a rock bed which is having magnesium carbonate. Fine. Now, this water, okay, right, the water is flowing. So I will write water as well. Now what happens? There takes place a reaction between this water and calcium carbonate or water and magnesium carbonate. But in the presence of carbon dioxide. Here, carbon dioxide also takes place, plays a role, okay, in this type of interaction of water with calcium carbonate or magnesium carbonate. And what happens is magic. Okay, these three reactants or these three substances react, okay, which means that our water is flowing through the soil which is having calcium carbonate or magnesium carbonate. So these two things are clear to you right now, I hope, right? And in the presence of carbon dioxide, okay, something magic happens, something reaction happens, and we get here in this case calcium hydrogen carbonate and in this case magnesium hydrogen carbonate. Okay, and these are soluble salts. Calcium carbonate and magnesium carbonate are insoluble. Okay, both of them are, but both of them are soluble. So they get solubilized in our water. Okay, and now see, if both of them are getting solubilized in our water, which means that these are present in our water. So see, if these are present in our water, water becomes hard. Got that point? So any kind of water source, if it comes in contact with such substances and such substances dissolve in that water, our water will become hard. As simple as that. Clear? Got that? Okay. Now let's move on to the types of hardness, which means simply that it simply means types of hard water. Okay, so we have seen right now water, we have divided into two parts, soft water, hard water, correct? Now, out of this soft water and hard water, our hard water is again of two types, or we can say the hardness is of two types. Okay, what are those two types? Temporary hardness and permanent hardness. Okay, now what's the difference between them? See, we all know hard water means out of those 6 salts, any one of them is present, water is hard. Now, in case of these two types of hardnesses, we say that water is temporary hard water when that water consists only, pay attention, calcium carbonate or magnesium carbonate, bicarbonate, sorry. Okay, calcium bicarbonate or magnesium bicarbonate, or we can say calcium hydrogen carbonate or magnesium hydrogen carbonate. If any of these two salts is present in our water, then our water is said to be temporary hard water. Okay, so out of these 6 salts, the first 2, if present in water, if these 2 only are present in water, then our water becomes temporary hard water. Okay, if only these 2 are present, then our water becomes temporary hard. Now, what is permanent hard water then, or what is permanent hardness so called? Okay, so permanent hardness means apart from these 2, if rest of the 4 salts are present, which are sulfates or chlorides. Okay, sulfates or chlorides of calcium or magnesium, right? So in order to simplify that, we can simply write calcium sulfate or magnesium sulfate or calcium chloride or magnesium chloride. Okay, so out of these 4 salts, if any of this salt is present in our water, then we call our water as permanent hard water. Okay, clear with this simple thing? Now, why we call the temporary hard water as temporary hard water? Temporary, why temporary? Okay, let's focus on that. Let's see the answer of this question in the next topic. Removal of hardness. Okay, this is our next topic, and in this topic we will see why our temporary hard water is called as so-called temporary hard water. Okay, now see, there are 2 methods which we are going to study right now. There are so many methods also to remove the hardness of water. Okay, to remove the hardness means to make the hard water soft. Okay, you just understand this thing. Make the hard water soft water. Okay, clear? Now for making this hard water soft, we are going to study 2 methods: boiling and addition of sodium carbonate. So now we are going to first focus on boiling, simply boiling. Okay, so we use this method. First of all, try to understand, we use this method to remove the temporary hardness only. Clear? Now let's see what we do. We simply boil the water. That's it. We don't do any rocket science here. So now we know, I have told you we use this to remove temporary hardness. So I'm considering water. Okay, see, I have taken some water, and this water is temporary hard. Okay, or temporary hard water. Okay, or it has temporary hardness, I can say. So just quickly try to recollect. Temporary hardness means what all things would be present in this water. Okay, till the time I write here, you just try to recollect on your own, or just pause here and then resume back to see whether you have recollected it right or wrong. Okay, so this temporary hard water, okay, it has 2 salts. It may have any one of these 2 salts, which is calcium hydrogen carbonate or magnesium hydrogen carbonate. Okay, fine. Just now we have seen. Now what we are going to do is, when we boil this temporary hard water, the calcium hydrogen carbonate or magnesium hydrogen carbonate in the water, what happens to it is, okay, it gets converted into this following products. Which are those products? Simply calcium carbonate, water and carbon dioxide. Okay, in this case it is magnesium carbonate. In the case of magnesium hydrogen carbonate, when we heat the water, okay, so magnesium carbonate, water and carbon dioxide is given off. Clear? See, when our temporary hard water is heated or boiled, okay, so temporary hard water either it would have this, or either it would have both of them, right? So I'm writing the reaction for both of them. What happens? Okay, suppose my temporary hard water is having both of them. Okay, now what would happen to these 2 salts? When heated, when we are heating this water, these salts will break down. Okay, these bicarbonates, so-called bicarbonates, calcium bicarbonate and magnesium bicarbonate, would be broken down, okay, into carbonates. Fine, calcium carbonates and magnesium carbonate. Okay, and along with it, water and carbon dioxide is also given off. So this reaction is simply the ulta, opposite of the reaction which we have seen just a few minutes ago. Okay, like here, see, calcium carbonate combining with water and carbon dioxide, giving us calcium hydrogen carbonate. This is soluble, this is insoluble. The same way, see, it's absolutely the opposite. Calcium carbonate, water and carbon dioxide, there they were combining, here they were reactants, here they are products. Okay, and there our product was calcium hydrogen carbonate, here it is the reactant. Okay, simply the reverse of that first reaction. But yes, what is actually happening here, we have to understand, these are soluble salts. That's why they are present in the water, and we cannot figure out, right? We cannot make out, okay, that our water is having these salts. Okay, and we also, when we cannot figure out that, okay, these salts are present, okay, it's not easy for us to remove them. But what we are doing here is, we are converting these bicarbonates, which are soluble, okay, in water. Very important. Okay, you need to understand this thing. So these bicarbonates, which are soluble in water, we are converting into carbonates. Okay, right? And these carbonates are insoluble in water. So now I hope you can use your brains and try to figure out if the soluble salt is getting converted into insoluble salt, what would happen? Our carbonates would start to appear, right? Since they are insoluble, so they would not be able to dissolve in water, and then they would finally settle down or something like that would happen, and then finally we can take this water, we can pour through the filter paper, or we can pour this water, okay, or we can filter this water. So after filtering, this precipitate carbonates, okay, these are the precipitates, would be removed from the water, correct? And our water would be now free from these calcium and magnesium salts, okay, because all the calcium and magnesium in the water is now removed as its carbonates, okay. So now our water would be free from this calcium hydrogen carbonate and magnesium hydrogen carbonate. Understood? Clear? So now if our water is free from this calcium hydrogen carbonate or magnesium hydrogen carbonate, then our water has become soft water, because it is not containing, first of all, the remaining 4 salts, okay. Since it is not containing, that's why we are calling it as a temporary hard water. It is only having these 2 salts, and now we are now successful in removing these 2 salts as well from the water, okay. How we have removed them? We have converted these 2 salts these 2 salts, which are bicarbonates, into their carbonates, okay, and in this way we have removed these salts. Clear? So our water has become soft water. Very nice, very simple, okay. So but there is problem with this technique, okay. What's the problem? If we are trying to make large quantity of temporary hard water into soft water, okay, so boiling is not that feasible, boiling is not that practical. Why? Because it takes so much time, and yes, it's too costly as well, okay. I will try to just erase this some part so that you would be able to see. It's not practical. Why? Because it's too costly and it's very slow method. Now let's move on to see the next method, how we can make hard water into soft water, okay. But now first let's see, okay, this method, okay. Now we have seen boiling. So boiling is used for removing the temporary hardness only, we have studied, but this method we can use it for removing both temporary hardness as well as for removing permanent hardness. So let's see one by one how we can remove temporary hardness by using this method, by simply addition of sodium carbonate, okay. So see, again temporary hardness, this means that our water is having either calcium bicarbonate or magnesium bicarbonate, okay. Now these things would have been like stick to your brain, okay, or our hard water may have both of them, okay. So we can write the equation for both of them. Now what we are going to do is we are going to add sodium carbonate to our temporary hard water, okay. So after addition of sodium carbonate, what happens, okay, if calcium bicarbonate or if magnesium bicarbonate or if both of them are present, so let's see how they react with our sodium carbonate. So what happens is, this calcium or magnesium, you just think in this way, it picks up this carbonate, okay, CO3 of this sodium, and this sodium, okay, which you can see here, this 2 sodium, 2 bicarbonates, 2 sodium, 2 bicarbonates, I'm telling you the trick to remember, okay. They pick up each other, okay, and they form the respective compounds. So now see, this calcium and carbonate, okay, would combine and they would form calcium carbonate, okay. See, since calcium is having calcium 2 plus, right, calcium is having here Ca2 plus charge, magnesium is having here Mg2 plus charge, okay, in this compound. So if you decode this, okay, with the help of the knowledge of radicals, and yes, with the help of the knowledge of radicals and the crisscross method, so you could figure out that in this compound, calcium is having 2 plus charge, magnesium is having 2 plus charge, okay. These all things we have studied in our chapter number 1. Now in this case, you would also figure out that our sodium and the carbonate, okay, in this carbonate is having 2 minus charge, okay, and in both of them carbonate is having 2 minus charge, okay, and sodium we all know it is having 2 plus 1 charge, okay, 1 plus charge, okay. So see, calcium 2 plus, carbonate 2 minus, they would combine, form calcium carbonate, right. Magnesium 2 plus, carbonate 2 minus, they would combine, form magnesium carbonate, okay. Now apart from this, what is now remaining? Remaining is 2 sodium, right, in this case as well, both of them. So 2 sodium 1 plus right? Again 2 sodium 1 plus, okay, in both the scenarios. And here HCO3, okay, bicarbonate anion, and how much they are? 2 bicarbonate anion. So 2 HCO3, okay, bicarbonate anion, 1 minus, bicarbonate has 1 minus, so 2 HCO3 minus, 2 HCO3 minus in both the cases, okay, 2 HCO3 minus 2 Na plus, 2 HCO3 minus 2 Na plus, okay, in this case also 2 Na plus 2 HCO3 minus, 2 Na plus 2 HCO3 minus, clear? So what they would form? See, 2 minus 2 plus, balance, charges are balanced, so Na2 HCO3, okay, here there are 2, so what they would form is 1 Na plus would combine with 1 HCO3 minus, okay, and another Na plus would combine with another HCO3, okay, just figure out. Let's make it easier. In both the scenarios, same thing is going to happen. So I'm erasing this one, okay, I'm erasing this thing, and now try to understand, okay. See, this 2 Na plus means, see, this 2 Na plus I have written it separately. This 2 HCO3 minus means, see, this 2 HCO3 minus I have written it separately. Now see it to yourself. Na plus HCO3 minus NaHCO3 plus 1 minus 1 balanced. So NaHCO3 would be formed. So NaHCO3 in this case, okay, and here also NaHCO3 is formed, okay. So I'm just talking about one case, okay, 2 Na plus 2 HCO3 minus, 2 Na plus 2 HCO3 minus, clear? So 1 Na plus 1 HCO3 minus would form NaHCO3, another Na plus another HCO3 minus would form another NaHCO3, so 2 NaHCO3 would form. In this case, same goes with this case, 2 Na plus 2 HCO3 minus, 2 Na plus 2 HCO3 minus. So again, splitting both the radicals, both will combine NaHCO3, NaHCO3. So 2 NaHCO3, so 2 NaHCO3. Okay, so reactions are very much similar, okay, because here the charges on the calcium and magnesium are also similar, okay, and we are only dealing about the bicarbonates here, okay, but I have tried my best to understand you how the products would form, giving you the trick as well, okay. So I could always means I could simply tell you that this and this would react and this would form, but I tried to give you some trick to remember and to see how the carbonates are getting out, okay, so that you could remember it better and it would be easy for you, okay, clear? How our sodium carbonate would make our water free from calcium bicarbonate or magnesium bicarbonate, making water free from both of this or any one of this. If any one of this is present and water and we are making it free from any one of this, then our water is becoming soft. If both of them are present and we are making by this method, okay, our water free from both of this, again our water will become soft, right? Correct? You know that simple logic. Clear? Now let's see our second method, how we can use it to remove the permanent hardness of water. Now permanent hardness of water would be because of the remaining 4 salts, okay, that is chlorides and sulfates of calcium or magnesium, okay, chlorides or sulfates of calcium or magnesium, okay. So to make it more simple, I can just simply write like this, chlorides of calcium or magnesium, okay, I would pick it this way first. So chlorides of calcium and magnesium are calcium chloride, okay, and magnesium chloride, okay, fine. And then sulfates of calcium or magnesium, so calcium sulfate and magnesium sulfate, okay. So out of this 4, if any one of them is present, our water is permanent hard water, okay. But don't go on that name, permanent hard water. Why? Because nothing is permanent in this nature, right? Everything has to change. This is the law of nature. So this water we can also change this water as well. From this permanent hard water, we can make it soft water, okay. Now coming back to one more interesting thing that I have told you, that why we call the temporarily hard water as temporary, okay, simply because we can remove the temporary hardness, okay, we can remove the temporary hardness by just boiling, right? So looking at the meaning, okay, temporary hardness, which means it's very temporary, just by boiling our water would become soft water. So that's why we call the temporary hard water as temporary hard water, okay, the term temporary, okay. Why? Because we can just remove the hardness by just boiling, okay, clear? Now, but permanent hardness is not like that, okay, we cannot remove the permanent hardness of water just by boiling. Then what we can do is, we can use the second method, addition of sodium carbonate, to remove the permanent hardness. Okay, but let's start from first. Let's see the example of calcium sulfate and calcium chloride. Okay, so if I take calcium sulfate, or simply if our water is having calcium sulfate or calcium chloride, definitely it is a permanent hard water. But now I am going to add again the sodium carbonate into this water. Okay, and again the same thing would happen. So here also you need to understand, our calcium would pick up the carbonate, here calcium would pick up carbonate. Okay, now what is left? This sodium and sulfate, sodium and chloride ions. Okay, so calcium 2 plus carbonate 2 minus, simply it would form calcium carbonate. Again here calcium carbonate. Fine. And what is remaining? 2 sodium ions. Okay, so in this first case, now we need to just divide the cases, because here the anions are different. Okay, so in this first case, see, 2 Na plus and 1 SO4 2 minus. Okay, in the second case, 2 Na plus 2 Cl minus, 2 Na plus 2 Cl minus. Okay, I'm just writing the radicals. Okay, I know sodium's radical is Na plus. How many sodium are there? 2, therefore 2 Na plus. Chlorine's radical is chloride, Cl minus, so I have written Cl minus. How many chlorine atoms are there? 2, therefore radicals will be 2. Okay, simply sulfate SO4 2 minus, I know, so I have written its radical, but only 1 SO4 2 minus is there, so only 1 SO4 is there, so 1 SO4 2 minus. Here again same, sodium Na plus, but 2 sodium are there, therefore 2 Na plus. Clear with this point? So now see, 2 plus 2 minus, balanced, charges are balanced, so now atoms would combine, so now radicals would combine. See, Na2SO4 they would form, since there are 2 sodium, so Na2SO4, correct? So now we know how to make the formula, Na2SO4. Okay, we have studied in the first chapter itself. Now in this case, see, again Na plus Cl minus. Okay, so see, here there are 2 Na plus, okay, and 2 Cl minus, right? 2 Na plus 2 Cl minus. Clear? So 1 Na plus will combine with 1 Cl minus, it would form NaCl. This would combine with this Cl minus, it would form NaCl. So how many NaCl are forming in this case? In this case, total 2 NaCl. So I'm just writing here 2 NaCl. Okay, so what all things were remaining for the first reaction? These two combined to form Na2SO4, right? Clear? 2 plus 2 minus balanced, so Na2SO4. Clear? 2 sodium atoms are here required and 1 SO4 is there, so Na2SO4 simply. So in this case, Na2SO4 is the another product in the first reaction. Okay, in the first reaction, fine. And in the second reaction, 2 NaCl is the another product. Okay, so 2 NaCl. Clear? Clear with the reaction? Now, if I take the scenario in which, suppose magnesium sulfate is there. Okay, so just by mere adding the sodium carbonate won't help us a lot. Okay, why? Because after adding sodium carbonate, okay, magnesium carbonate doesn't come out completely. Now see, in this case, in the temporary hardness case, okay, what was the scenario? We have removed the calcium bicarbonate and magnesium bicarbonate, okay, in the form of their carbonates. Okay, so I haven't explained you this because in the previous one we have seen this thing only. This soluble bicarbonates of calcium and magnesium have been converted into insoluble carbonates of calcium and magnesium. Okay, so what we have studied, these insoluble carbonates would be present in the water, so we can filter and remove these insoluble carbonates and our water would be free from these two salts then. Okay, so in the same manner, this way, in this case also same thing happens. These two bicarbonates, okay, calcium bicarbonate, magnesium bicarbonate, they are converted into, okay, these are soluble, they are converted into insoluble. Okay, insoluble we just denote it like this arrow because it is precipitating out. Okay, it is getting settled down. Okay, so just this downward arrow. Okay, so this is precipitating out, so this is insoluble, so we can filter, okay, in our water. Okay, it would just settle down like this. Okay, so we can filter out our water and this thing, this insoluble part would be present in our filter paper, so our water would be now free from the salt. Okay, how we made it free? Since these were soluble, so we cannot separate it. So what we did is we just converted these two bicarbonates of calcium and magnesium to carbonates of calcium and magnesium. Okay, and these carbonates of calcium and magnesium, since they are insoluble, we just filter off, and in this entire process, our bicarbonates, they have been we have got rid of these bicarbonates. Okay, by converting them into the carbonates and then ultimately removing them off. Okay, so this method in the addition of sodium carbonate, okay, when we were removing temporary hardness. In the same case, here also we are doing the same thing. We are converting the sulfates or chlorides of calcium into carbonates of calcium. Okay, so these are soluble. Okay, every salt which I have written here in this first slide, every salt, this is soluble in water. Okay, that's the reason we cannot separate them from the water. Okay, so we need to do such brainstorming things to boil them or to add sodium carbonate so that we can get rid of these salts. Okay, clear in your brain? So now moving ahead, here also the same scenario is taking place. We have converted our calcium sulfate and calcium chloride, which are soluble in our water, into insoluble calcium carbonate. And this insoluble calcium carbonate we can just remove by filtering the water. Okay, because since it is insoluble, it would get trapped into the filter paper. Rest water would be free from the calcium sulfate and calcium chloride ultimately. How? Because we have converted into this salt then. Because we have converted this two salts into this salt. So ultimately since we have got rid of this, we can say that we have ultimately got rid of this. Clear? But the problem here arises when we are talking about magnesium sulfate. Okay, so what I would do is I would just remove some space from here. Okay, I will just erase it off. So when magnesium sulfate is present, okay, let's start from this here. When magnesium sulfate is there, by mere addition of sodium carbonate, okay, we would not be able to okay, remove this magnesium sulfate completely. Why? Because since we have studied till now that these salts are converted into their carbonates. Okay, so same way, if we follow the same type of method, our sodium carbonate, when it is added to the water which is having magnesium sulfate, what would happen? Magnesium would shake hands with our carbonate and this sodium would shake hands with our sulfate. Okay, so ultimately what is going to form? Magnesium carbonate, sodium sulfate. The same case like that of the calcium. Same case. Okay, just now a few minutes we have seen for calcium sulfate. Okay, the same case. But the problem here is in case of magnesium sulfate, okay, the magnesium carbonate which is precipitated out, okay, or which is formed, it's not complete precipitation. Okay, not all magnesium sulfate would get converted into magnesium carbonate. So then our method would become ineffective, right? Because we would be only successful in converting some of the magnesium sulfate to magnesium carbonate. So now we have to think of some other thing, right? For that reason, what we do is we just don't stop here. Okay, what we do, we just don't stop adding sodium carbonate. We need to add one more beautiful chemical substance, which is slaked lime. Okay, calcium hydroxide. You would say, sir, what all things you just tell? What is beautiful in this calcium hydroxide? Okay, this substance, this chemical is very much beautiful. I'm telling you just as a joke. Okay, because it has some reactions and those reactions are quite important as well. So I'm telling you in the funny way. So this calcium hydroxide, which is called as slaked lime, we add, okay, along with sodium carbonate, and then our magnesium sulfate can be completely, okay, removed. Okay, how we remove these substances? Indirectly, we remove them indirectly, but yes, but we are successful in removing them. Okay, so what happens here is the reaction which takes place. Okay, we get the products as magnesium hydroxide. Okay, this magnesium picks up this hydroxide here now. Okay, it doesn't pick up the carbonate. Okay, so this picks up the hydroxide. Our calcium picks up the carbonate. Okay, and rest is sodium sulfate. Okay, so magnesium picks up hydroxide, calcium carbonate and sodium sulfate. So 2 sodium, 2 sulfate. So here, sorry, 2 sodium, 1 sulfate. Okay, so Na2SO4, 2 sodium, 1 sulfate. Clear? So if you would balance it off as well, it would be same: magnesium hydroxide, calcium carbonate, Na2SO4. That's it. Okay, it's completely balanced. So this would be our products. In short, I'm trying to tell you. Now out of this is not soluble in water. Okay, so we are successful in removing our magnesium sulfate somehow in the form of magnesium hydroxide. Okay, and now it is completely converted. Okay, magnesium sulfate, all of the magnesium sulfate would be converted into magnesium hydroxide. So we are now successful in removing all of the magnesium sulfate from our water. So if we have removed it, this means our water is free from magnesium sulfate. That's it. We are done, right? Because if it is free from magnesium sulfate, we can say it is now soft water. Okay, the scenario is if our water is only having magnesium sulfate, so now it would become free from our magnesium sulfate. Okay, clear? Got this point? Now here this is also insoluble. Okay, and this is soluble salt, but we don't care about the presence of sodium sulfate again. Okay, they may ask you that our water contains sodium sulfate. Is it soft water or hard water? You can say no. Okay, sorry, is it soft water or hard water? So you have to say it is soft water. Okay, simply soft water. Why? Because it doesn't have chlorides, sulfates or bicarbonates of calcium or magnesium. Here it is having sulfate but of sodium. Okay, we don't have any problem with the sodium sulfates in our water. Okay, if they are present, we don't call our water as hard water. Clear? Clear the entire concept? Okay. Okay, now let's move on to the advantages and disadvantages of hard water. Okay, so it's a very jolly topic. It's very means close to our daily life application topic. So see, first advantage is it is used in the preparation of beverages and wines. Okay, now why is this so? Why hard water, okay, is used? Because see, if we take water which is free from the salts, okay, for example, like we know, if the water is free from the list of that 6 salts which we know now, bicarbonate, sulfates and chlorides of calcium and magnesium, so that water's taste, which is like soft water, we know that water is soft water first of all, and this soft water's taste is very flat. Okay, it is not very tasty. But if we consider hard water which is having those 6 salts which we know now, our water starts to taste little bit tasty. So that's the reason, okay, since our hard water is slightly tasty because of those salts present in that water, that's why we use in the preparation of these beverages and wines, because we need the taste in these beverages and wines. Correct? Chalo, moving ahead, our hard water, okay, if it is having calcium or magnesium salts in very small amount, okay, calcium and magnesium salts in small amounts, okay, so they are very much essential for the growth of bones and the teeth in our body. Okay, fine. So yes, in small amounts these salts are essential for us. Okay, so if very small amount of these salts are present in our water, or we can say if our water is very slightly hard, then don't hesitate to drink it, because it is okay to drink it. Okay, but very slightly hard. Okay, now that you cannot know how much calcium or magnesium salts should be present. Okay, so don't try to experiment with that. So telling mother that I would drink hard water, it is very slightly hard and all those things, no need to do all those things. Okay, you just simply drink the pure water which is coming to you, or simply you can drink the river water if you are going for treks and all those things. So the river water has naturally a very good amount of salts, okay, which are like almost in a permissible limit. Okay, fine. Now moving ahead, the another interesting, okay, advantage of hard water is it checks lead poisoning. Okay, now what is lead poisoning? So see, not now, but some years ago, the houses were having the pipelines which were made up of lead. Okay, lead. Now this lead pipes, okay, when we are passing the water through these pipes, this lead salts okay, were getting dissolved in our water. Now see, if the lead which is present in the water is above the permissible limit or above the dangerous limit, so called dangerous limit, so this means that it is harmful for us, okay, and we may be getting poisoned by the lead. So what hard water does is, hard water puts a check on this lead poisoning. How? If hard water is passed through the lead pipes, what it does is, the salts which are dissolved in the water, okay, this hard water just makes this salt insoluble, okay. The salts which are present in the water, now they become insoluble, they are removed from the water, okay, if hard water is going through the pipeline, okay, removed from water. So now if the lead salts are removed from water, now what happens is, our pipeline, okay, you know, something like that, okay, don't worry, don't bother about my circle, okay, I've tried. So something like this circular pipe is there. Now when lead salts are being removed from the water, okay, so in short, our hard water is making the lead salts insoluble, okay, insoluble from the water. Now insoluble means they are not getting dissolved in water. So these lead salts start to deposit on the inner lining of the pipe, like this, okay. Now by looking at this inner lining of the pipe accumulated with such salts, okay, we can figure out that, okay, so yes, the water which is coming is absolutely hard water, because hard water only can make these things, but okay, the water which was coming, it may have some lead if the water was not hard water. Clear? So since the hard water was coming through this lead pipe, it just pushed out the lead salts, and these lead salts were deposited on the inner side or the inner lining of the pipe, okay. So this hard water saved our life. In short, hard water kept the lead away from the water, okay. But this doesn't mean that you need to drink hard water, okay. It's just a indicator of lead poisoning. Clear? Got this point? Hard water can just indicate that, okay, the lead pipes are leaching, okay, or the lead from the pipes is leaching. Clear? Now moving ahead to the disadvantages. Now let's see what are the disadvantages of hard water. So see, hard water cannot be used for production of steam, okay. Why is this so? See, in industries where steam is produced, we have boilers, and in those boilers, okay, when the what actually is there in that boilers? That boilers have the copper tubes, okay. So now these tubes through which the water is passed. Now if hard water is passed, what happens is, okay, we heat this entire thing, so water gets converted into steam, right? Yes, after heating. But water is having some dissolved salts because it is hard water, right? That 6 salts it is having. Now this dissolved salts start to just accumulate on the inner surface of the pipe, okay, and slowly and gradually this inner lining gets thicker and thicker, like this, okay, making the lumen of the pipe, or we can call it as the bore of the pipe, okay. Suppose this is the bore before, okay, and after getting accumulated with the salts, the bore becomes smaller and smaller, okay. The size of the hole of the pipe becomes smaller and smaller, okay. So now what would happen? The hard water is passed, still it is passed. Clear? So what can be the consequences? See, less and less hard water will be able to go through this pipe. Correct. Second would be the steam which is produced here, okay, less and less space is there, right, in the pipe. So steam would be now putting up a lot of pressure on the pipes, so the pipe may get burst as well, okay. 2 things we have seen through. And the third thing is, since these pipes are getting accumulated with this dissolved salts, so what would happen is, we are heating it, right? We are heating to make the water convert into steam, so to convert the water into steam. But this salts, okay, they would act as an insulation. So whatever heat we are giving, okay, these salts are like bad conductors. So whatever heat we are giving, some of the heat is being trapped. Okay, some of the heat is not being allowed to reach the water. So whatever fuel we are using to make the heat, okay, out of that fuel, lots of fuel is getting wasted, right? Because whatever heat we are producing, all that heat is not getting used for conversion of our water to steam. Okay, so the process becomes less efficient. So now what we can do is we can simply remove this apparatus, remove this system, remove these instruments, okay, after over a period, and then we can remove the inner lining, okay, of this insoluble salts which are formed. That's the thing which we can do. Clear? But ultimately, okay, what's the problem? We cannot use hard water because it has so many problems. So what we can do is we can, instead of this removing such after a certain period of time, instead of removing the instruments, pipes and cleaning them, what we can do is we can simply use soft water, because soft water will not have such salts. Okay, clear? Got with the point? Okay, soft water may have some other salts, but we may take care that yes, instead of using hard water, at least soft water doesn't have this salts. Okay, so it would be easier for us. Less and less salts would get, or less and less would be the deposition of the salts, okay, in the inner surface or the inner lining of the pipes. Okay, clear? For making the steam. So we can use soft water. This is my individual view. Okay, so because it's obvious, it's very logical, because soft water would have less salts as compared to the hard water. So less would be the deposition on the inner lining, and less would be the efforts taken. Less efforts we have to take again and again to remove the instrument and to clean. Okay, clear? Okay, moving ahead, this hard water, okay, again it is forming such problems. So in geysers, okay, the application which is applicable to our daily life is geysers. So you may be using geysers in your houses, and what you do is you heat the water, correct? But when you are heating the water, some of the water, okay, may form into steam, or it may not form into steam, but some of the calcium hydrogen carbonate or magnesium hydrogen carbonate present in the hard water may get converted into calcium carbonates or magnesium carbonate, right? Because temporary hardness can just be removed by boiling. So in the geysers, okay, when we are heating the water, our bicarbonates of calcium or magnesium may get converted into carbonates, and these carbonates are insoluble, so they may form the lining inside the geysers. So geysers may get damaged, right? In this way, because the inner lining of the geyser now would be accumulated by the calcium carbonates or magnesium carbonates. Okay, so now our geyser would not function properly, because whatever energy we are giving to the geyser, that would not reach the water effectively, and slowly and gradually our geyser would stop working also. Okay, it may stop working also. Clear? Because of the choking due to this accumulation of salts, calcium carbonates, magnesium carbonates. Okay, moving ahead, it is also unfit for washing purposes. Now what does this mean? Okay, very interesting thing. Mostly hard water, okay, we cannot use to wash the clothes when we are using soaps. Okay, why is this so? Now see, soap is chemically sodium or potassium salt of long chain fatty acid. Okay, now I will take an example so you can understand this thing. Okay, sodium salt, so I'm just taking sodium here, of long chain fatty acid. So suppose I'm taking stearic acid. Okay, so stearic acid is, its formula is C17H35COOH. Don't worry, I'm just writing the molecular formula. Now when I'm talking about the sodium salt of this acid, this means that H of this acid is replaced by the Na. So this would be C17H35COONA. Okay, this would be minus, this would be plus. Fine. So this is the negative part. Okay, this is the positive part of this substance. Clear? Don't worry, no need to go into the details. So we can simply write this as Na. Okay, Na, and this entire thing as St. Okay, so sodium stearate, we call it as sodium stearate. So sodium stearate. short form. So now our soap is simply sodium stearate. Fine, we got to the simple thing. Now our hard water has, we all know, calcium hydrogen carbonates and magnesium hydrogen carbonates and whatnot. Okay, so this calcium and magnesium salts, now let's take any of the salt. Suppose I'm taking calcium hydrogen carbonate. Okay, what they actually do is the calcium replaces the sodium, okay, from this sodium stearate. Okay, now what would happen? See, calcium replaces the sodium. Okay, now I'm just writing the react product. Okay, so see here, the calcium is in Ca2 plus. Okay, here our sodium is in Na plus, right? Only 1 plus. Fine. So if our calcium wants to combine with this stearate, because stearate is also having 1 minus, correct? So 2 plus charges are there with calcium, here only 1 minus, so we need 2 stearate, correct? So 2 minus 2 plus would combine, so that's the reason. Now here we need 2 stearate, so I would just write 2 here in this reaction. Okay, so 2 stearate. So now we have to give sodium, means we have also to take, we need to take sodium also too. Okay, fine. So now this calcium would replace these 2 sodium atoms, you can say like this, 2 sodium, and form CaSt twice. Okay, see, calcium 2 plus 2 St minus, CaSt twice. Clear? Just focus on this 2. Calcium 2 plus 2 minus, so balanced CaSt twice. Okay, now what is remaining? 2 sodium plus and HCO3 minus. Correct? So 2 Na plus HCO3 minus. And how many HCO3 minus would be there? 2 HCO3 minus. Correct? So 2 plus 2 minus. Okay, means simply here 2 sodium plus and 2 HCO3 minus. Now we know this thing. Okay, 1 sodium plus would combine with 1 HCO3 minus, right? Here I will write 1 sodium plus would combine with 1 HCO3 minus, would form NaHCO3 simply. And same, the another sodium plus would combine with another HCO3 minus. Since there are 2 na, and it would also form, see, another Na plus would combine with another HCO3 minus, and it would also form NaHCO3. So there are 2 NaHCO3 which are formed. So 2 NaHCO3. Okay. Now let's reach the conclusion. What has actually happened here is, from this reaction we can figure out our sodium stearate is now converted into calcium stearate. Okay, so this sodium salt is now converted into the calcium salt, and this calcium salt is not soluble in water. Okay, so our salt, okay, this sodium stearate is no longer present now, okay, in water, because it is being converted into calcium stearate, and this calcium stearate is not soluble. So this calcium stearate which is formed is called as scum. Okay, now you can just remember here, or you can just understand this thing here. In order to wash the clothes, in order to clean the clothes, in order to remove the oil and dirt from the clothes, we need our sodium stearate, okay, to be present as sodium stearate only. Okay, clear? Why? Because in water, what happens when the salt, when salt comes in contact with the water, this sodium stearate, this compound, it just breaks down into sodium ions and this stearate ions. And you would study in your higher classes, this stearate ions are actually responsible for the cleansing action of soap. Okay, no need to go into details here right now. You just need to focus on this thing. This we need in our water. But if the sodium stearate remains as sodium stearate, so this is present and this stearate ions are present, and they would work and they would function properly, okay, and they would remove the dirt and oil and all those things, and they would clean the clothes. But if calcium stearate is formed or magnesium stearate is formed, okay, in the same way, if I take magnesium hydrogen carbonate here, so if magnesium stearate is formed or calcium stearate is formed, this calcium or magnesium is insoluble. This means that it doesn't leave these stearate ions in the water. So now these stearate ions along with calcium are present out of the water. Okay, so if these stearate ions are present out of the water, how they would clean our clothes? They won't be able to clean our clothes. And that's the reason, okay, our hard water doesn't form lather. The very first thing which we have studied, that soft water readily forms lather, but hard water, it doesn't readily forms lather. Why? Why readily? Okay, hard water also forms lather, but when it would form lather, when all the calcium and magnesium, okay, ions which are present in the hard water are converted into this scum, and now our water is free from calcium and magnesium ions. So at that point, our hard water would start to form lather, okay, because at that point only this compound would stop getting formed, and now our sodium stearate would remain as sodium stearate, which means that our stearate ions, okay, are present in the water and they would function properly. Clear? Okay, I know it's a little bit complicated, but I have tried to explain you this thing, okay. So I hope you would have understood this thing, right? Okay, chalo. One more interesting thing. Now, whatever scum which is formed, there is one more problem with the scum. It is very difficult to wash out from the fabrics. Why? Because it is very sticky and it sticks to the fabrics. Okay, so that's another problem of scum. So now let me tell you one more interesting thing. So it's not like we should study as per our syllabus, but one more interesting thing in all this entire story of hardness, okay, and you may be thinking that, oh, the soap cannot be used along with hard water, so now how to wash the clothes and all those things. A very simple solution you already use in our houses is, okay, using the detergent, okay, synthetic detergent. So synthetic detergents, what happens in the case of soap, okay, the stearate ions, okay, those ions are not free, okay, to work. But in case of synthetic detergents, okay, in this case also the calcium and magnesium salts are formed just like this, okay, calcium and magnesium salts are formed, but now there would be some another chemical compound, because synthetic detergents are slightly different from that of the soaps. No need to go into that much detail what are synthetic detergents made up of, but whatever salts of calcium or magnesium are formed, okay, when we are using synthetic detergent, they are not like scum, okay. Why? How is scum? Scum is not soluble, but this is soluble, right? So since it is soluble, okay, whatever negatively charged part is there, okay, whatever it may be, okay, no need to go into that detail, but whatever negatively charged part is there in this salt, that negatively charged part would be now free in the water, okay, and we need that negatively charged part, right? Like in the case of soap, we need this negatively charged part. In the case of detergent, there may be some another negatively charged part. So that part is free now, and since it is free, so it can act, it can remove the oil, it can remove the dirt, it can clean our clothes, okay. So if you are having hard water in your house, but now if you are puzzled how to wash the clothes, simply buy a detergent and your work is done. Don't use soap. So now friends, it's time to see how much we have understood till right now, till this point. So let's quickly see some questions, okay. I won't take your much time, but let's go through some questions. The salt which is the cause of hardness in water, okay, just read it carefully and then give the answer, because in bit of hurry you may go wrong, okay. So the salt which is the cause of hardness in water is sodium sulfate, magnesium bicarbonate, sodium chloride, calcium nitrate, okay. So you can pause here, you can answer, and then you can again resume back to see the correct answer. This is what I feel you should do, because then only you would be able to check whether how much you have understood the things, okay. So I hope you would have tried this definitely. Now let's see what the answer is. So when the question is saying the salt which is the cause of hardness in water, okay, so water becomes hard, or the cause of hardness in water is because of those 6 salts which we have studied, okay, which are like chlorides or sulfates or bicarbonates of calcium or magnesium, okay. Now if we would make it simpler, you know, I have already written calcium chloride or magnesium chloride, calcium sulfate or magnesium sulfate, calcium bicarbonate or magnesium bicarbonate. Out of these 6 salts, if any of the salt is present, then our water is hard, okay. So the salt which is the cause of hardness in water is, so we need to simply see out of these 6 salts if some salt is present or not in the option. So sodium sulfate, no, sodium sulfate out of these 6 salts, it is not there, okay, because our salts are of calcium or magnesium, so this is eliminated, okay. Next is magnesium bicarbonate, okay, magnesium, Okay, wait a minute. Because magnesium salts of chloride, sulfate and bicarbonates are the cause of hardness, right? And here it is magnesium bicarbonate. See, magnesium bicarbonate. So yes, we got our answer. Okay, let's see the next options. Sodium chloride, we don't deal with the sodium salts. Sodium salt, we don't care about sodium salt if they are present or not. That doesn't conclude that our water is hard or no hard. Okay, if sodium salts are present, our water is soft. Okay, our water is only and only hard, I'm again repeating, when only these salts are present. Okay, these 6 salts. So sodium chloride, no. And then calcium nitrate. So calcium nitrate also no, right? Because it doesn't fit with this list of the 6 salts. Clear? We got our answer. Next is temporary hardness of water can be removed by. Okay, see, options are adding NaCl, absolutely not. Okay, boiling, yes, we can remove temporary hardness of water by boiling. Yes, just boil it and our temporarily hard water will become soft water. How it would become, if you want to know, you can go back in the video and just watch it again. Okay, if you have some doubts. Then adding calcium carbonate, absolutely not. Calcium carbonate itself is insoluble, right? So how it would make our temporary hard water soft? Okay, when we add calcium carbonate in our water, it would just stay like that only. Okay, leaving it for a few hours. Okay, this is a rubbish option. Okay, means this is not at all applicable. Leaving the water for a few hours will not make our water soft. Okay, so our water would become, temporary hardness of water can be removed by boiling. Clear? Next question. Now you need to apply some brains here. Okay, if magnesium sulfate is present in hard water, hardness can be removed by. Okay, we have already studied this. So just put some stress on the brain and try to answer out of these 4 questions. So I hope you would have paused, you would have tried, okay, and then you have been again resumed the video to see the answer. So see, if magnesium sulfate is present in hard water, fine. If magnesium sulfate is present in hard water, hardness can be removed by only adding sodium carbonate. So no, we have seen, right, when we were studying, only adding sodium carbonate doesn't work with magnesium sulfate, because it doesn't completely get rid of this magnesium sulfate, right? Because when it reacts, the magnesium carbonate which is formed, okay, not all magnesium sulfate is converted into magnesium carbonate. So that's the problem. So that's why we don't only add sodium carbonate. Okay, so this is wrong. Okay, we add something else, right, with the sodium carbonate. Let's see if it is present in the options. Second is boiling. Absolutely no. Boiling doesn't remove magnesium sulfate. Okay, boiling doesn't remove permanent hardness. Put this thing in your brain, very clear. Boiling only removes temporary hardness. Next, adding calcium carbonate, again the same thing, calcium carbonate, CaCO3, it would just remain as it is in the water. Okay, nothing would happen. Fine. And then lastly, adding sodium carbonate and slaked lime. Yes, it's the correct option, because we have seen the reactions, okay, regarding the hardness of the water, and here it is. See, we add along with sodium carbonate slaked lime in order to remove magnesium sulfate completely. Okay, so our question was also dealing with the same thing, how we can remove the magnesium sulfate from the water, right? So we can remove it by adding sodium carbonate along with slaked lime. Okay, clear with the answer? So friends, with this we have reached the end of this video and the end of the concepts of this chapter as well. So we have completed the entire chapter through these 3 videos. So I hope you would have enjoyed learning with me. You would have understood the concepts which we have learned so far. But please do let me know this thing in the comment section. I would be waiting for your comments. And as you all know, LearnoHub matlab free hai par best hai. So see you in the next video with the next concepts of with the next chapter, right? With the concepts of next chapter. Till then, you keep studying. Stay tuned. Bye bye, and have a great day.